Right. Well, let's start super basically. I'm going to use Vim and editing the default.nix file. That's the file Nix evaluates by default. So let's open the file and some super basic Nix stuff. Let's just do like a null, like the simplest value. And then I can evaluate this using, so there's an old way to evaluate things and a new way to evaluate things. The old way to just evaluate the Nix value is kind of convoluted. It's Nix instantiate -- eval. Ideally, it should just be Nix eval, but legacy eval, and that should be it. Yeah, so it evaluated to null. That's the default of Nix file. We can also pass the file name explicitly, default.nix, and that also works. Generally, you don't have to use Nix instantiate eval because in here you have like a derivation or something. Generally, with Nix, you want to build derivations instead of just evaluating Nix itself. But yeah, let's start with evaluation for now. So you have simple values. One of the main data structures in Nix is the attribute set. Let's add like names here. Attribute set. That's just a dictionary known from almost every language out there. You can have keys and values. Keys don't need to be quoted like in JSON. There's an equal sign and a semicolon at the end. You can quote keys as well. That is needed when you have special symbols in here, for example, like a dot. So we can evaluate this. This evaluates to just what you see. But if we were to use this literally, like this would nest it in another set. So this is, what is it? Syntactic sugar for foo equals another attribute set or equals null. So it just nests it automatically for you. Let's quote this out for now so we don't get like conflict. Yeah, and so if we, oh, I didn't save, I think. No. Oh, I declared foo here already. So yeah, maybe that's good to see. See an error here. Attribute foo.bar already defined. Hold on. Foo. Okay, that's an error in Nix. Jeez, it's starting out well. So apparently it says foo.bar is already defined, but then it points to, wait.
Is it because of the string one on line 4, or are those
I don't
things?
think it should be. Those should be different. I can comment it out to see. Yeah, no. Okay, so apparently, so that is really a conflict, because if we syntactically desugar this, I guess it does make sense. You have one for null and one for the attribute set. All right, so I think it was just like an error in the error message. But yeah, that's conflict. You can only define an attribute once. And so that is sometimes a bit tricky to see. Sometimes you have like a big Nix file and you do like foo.bar somewhere, and then later down you do something else with foo. But yeah. Okay, well, let's continue on. We can some other values. Yeah, integers. We also can do operations with integers. We can do like addition, division, subtraction. Integer derivation is like it doesn't use floats. It just this would give 0 here. Let's see. Oh, we still have this error, right? It's like who's. All right, and here we're coming into lazy evaluation the first time. So if we just do the Nix instantiate eval, it shows like a code here, which means that it hasn't evaluated this fully. This is a bit of a detail to how it's implemented, but we can just add a strict here to force it to evaluate the whole thing. So then we can see the full values here. There's also floats. Floats aren't often used, but if you just add like a dot, I think it converts the whole expression to a floating thing. Or only this part. I think you need one here as well. I think like if there's at least one floating operation in the pipeline, it turns it to a float. All right. There is a weird thing going on where it only prints the first 6 digits, which is oftentimes a bit inaccurate, but something to fix in Nix. Then some other, what do we have? Floats. We have strings, of course. Bar. Then strings can have interpolation. Certainly, we need variables for this first. So let's look at variables. So variables, we can do a let in statement to declare variables. So we can say let some variable equals 10 in, and then the expression we want to evaluate with that variable in scope. And so we can say some variable plus 1. So let's evaluate this. All right, that works. Let's go down a bit here. And so with variables, we can then also use interpolation. So we'd say let some variable equals 10, or we need generally actually you don't need variables for interpolation, I'm just realizing. But let's use like this for now. So we can have some string, or let's say some name equals my name, Silvan. Hello, some name. So this is how interpolation looks like in Nix. The dollar curly brackets. All right, and then in here, you can also do, like this is a general Nix expression here. You can put anything here. So you can also add like a plus. Plus, by the way, is also for string concatenation. So then let's add my last name here. So you can do this. This is the quotes do get a bit confusing here, but string addition here. This is the same as just like interpolation 2. This is the same as just moving the most paragraph out here, like this. That makes sense. Then, of course, we can also do more complicated operations in here, right? That's any Nix expression. So we could do like a equals 10, and then multiple variables. You just add more of them. Oh, you need a semicolon though. Equals 20, and then we could do something like a plus b. Now this will throw an error because string interpolation needs a string. So if we were to evaluate this, oh, interpolation already defined. So like this. Yeah, so this says cannot curse an integer to a string. Makes sense. There are built-in functions in Nix which we can call from anywhere. And so one of these functions is toString. This converts pretty much anything to a string with some weird behavior as well. Parentheses to make sure it doesn't just convert the first one. And then this should work. Yep. Right, so toString useful built-in function. There is some, like, let's use this toString example. Let's do like, so this is some weird behavior, but toString of false. Oh, and actually, let's do two-string example, it's kind of hard to see the output here, but if we look at this, it turns into the empty string.
Right.
And that comes from bash. Like,
Yeah. Okay.
makes it simple to have that work for bash. Yep. Empty string and 1. Yeah, but it works for integers. It also works for other things, but let's get to that later. Then what other basic things do we have? Right, we have, of course, attribute access, or attribute selectors is maybe the right word. So let's say we define some attribute set here. Let's say call it foo, and we can also use the dot syntax here. So that's foo.bar.bas equals 10. Let's also do like foo.bar.cux equals 20. Right, and internally Nix combines these into a single one, so this should be valid. And so then we can also access these attributes, of course. So we can say access foo.bar.bas. That's how you access these attributes again. So this just evaluates to 10. Let's maybe do it like this. That's kind of easier to see. All right, so this works. We can also do defaulting, where let's say we try to access an attribute that doesn't exist. Hello. Now, if we try to evaluate this, we get attribute hello missing. And so what we can do as a fallback is to use the or operator, and we can say or 30. This means that if this attribute doesn't exist, just use return 30. So if we do this, we get 30 here. That also works kind of nested. That almost works for anything, actually. So you could say like hello.foo.bar. That also works. Yes. All right, but that is a common gotcha because the or isn't the binary or operator. Those two exists. Boolean ops to like let's do like true and false. So that's these kinds of operations. We have this one. We also have the implication false, and the implication is really just if the left one is true, then the right one needs to be true as well. It can be desugared to this, I believe. Yeah, it's sometimes useful. Is there any other? Oh, there's not, of course. The exclamation mark is not. All right, so we have that. Let's see what would be next. We have string interpolation. We have this variables functions, I guess, would be a good next step. Funs or some fun equals. So you declare functions with the colon. So declare the name of the function argument, then a colon. And then let's return x plus 1. So that's in like, I know, Python, it would be, do I know Python? Some fun x. I think that's right. Return
looks
x plus
right.
1.
I don't know Python, but it looks good.
Yes. And then if you want to take multiple arguments, you just kind of, one of the ways you can do it is just to do it like this, x plus y, and just take an argument, return a function. So this is just this. And then you use currying to apply this. So let's do like f equals this, and then in f1, 2, like this. And here, let f equals f1. So this, are you somewhat familiar with functional programming?
Yeah.
From Haskell, maybe?
More from Scala, but I know a bit of Haskell.
Nice. So do you know about currying already?
Yes, yeah.
Nice, nice. Yeah, so this is one way to apply multiple arguments. Another is arguments can be you can take an attribute set, or you can destructure an attribute set as an argument. So let's do attrs like this. So the way you can do this is by kind of taking an attribute set here. So let's say we have x, y like this, and x plus y. And so this is a function that takes an attribute set with exactly the attributes x and y in it. So this way we can do x equals 2, y equals 3. This is generally the recommended way to declare functions, because you can name arguments this way. And also it's easy to add additional arguments later in a way that doesn't break all the code. Because if you were to add an extra one here, it would just break this and return a function now. Whereas if you add one here, you get an error where z isn't provided. Now these function arguments have some other capabilities. So something else is you can take an ellipsis, is what it's called. This allows you to take and ignore arbitrary other arguments. So you could, how should we do this? Let's do like this. Then we can do x equals 2, y equals 3, ignore it equals 4. You can do this. You can also default arguments.
Sorry, if you don't have the ellipsis, does that mean that it will only accept an attribute set with exactly x and y, or?
Exactly, yeah. If you don't provide one, it will get an error, and if you provide something else, it will also provide an error.
Okay.
Yep. Right. You can also not provide one that's given here if you have a default here. This can be done with the question mark. So you can do like, let's give x a default of 1. That's again an arbitrary Nix expression here. So default of 1, and then we don't have to pass this. There is some arguments against, so these defaults don't work super well sometimes. There's other ways to do this better sometimes. Let's go with this for now. Let's also, oh yeah, this is kind of weird here. Let's do x plus y. Here also x plus y. So what you can also do is capture the entire attribute set that's passed here. Kind of, let's say you had something like this and something like this. Attributes. Actually, yeah, let's do this plus attributes.y, y like this. Oh yeah, and we can like make a whole combination here. So these are almost equivalent. So the first one like explicitly destructures the attribute set, defaults x to 1, and then adds them, x and y. And this here accesses x and uses the OR operator to default it to 1, and also accesses y. So that's a good example. There is one slight difference where the kind of destructuring of the attribute set here happens before the function even starts evaluating. Whereas here it doesn't happen before. Like this is just a variable; it doesn't get evaluated if you don't without this. But you can also somehow combine these a bit, and that's by to like fg by using address at. Actually, that also works the other way around. Let's do like a flippity here. Address. This also works. And then you can both get this destructuring here, and you can catch kind of the address itself. And so this way you can, you could do this, for example, address.y, or let's do x plus y plus, let's see, address dot ignored or not ignored. So that works. You can, let's go to like if expressions as well, real quick. So very basic: if true, then false, else true. I don't know, something like this. Or if 1 plus 1 equals 2, then yes, else no. And you can provide different types here as well, by the way. So which is interesting because yeah.
Sorry. I was going to ask, does the condition have to be a Boolean, or could it be like, or do other values have truthiness, I guess?
Yes, it has to be a Boolean.
Okay.
Anything else doesn't work.
Great.
Yeah. Yes, and so if we can also kind of combine. Sorry, let's make like let's say we have like a function maybe argument where we do something like, so we declare a function and we say the function takes like an x, a y, and address, and then let's do like, well, that's also an ellipsis, so we can even get other arguments. So like x plus y plus, and let's do like an if address. Oh yeah, we haven't. Okay, we need to first talk about something else here. So we can check for attributes. We can do something like this, or is it like foo.bar.pass equals 10. And then we can check whether it contains a certain attribute without having to access or evaluate it. That's with the question mark operator. So we can ask, does this contain bar? And this also works with full pass. So we can say, does this contain bar? And does bar contain bass? And so in this case, this would evaluate to true. This would evaluate to false, and so on. And so this way in here, we can check whether address contains like not, or maybe, or actually not ignored. So we check whether it contains a not ignored. If it does contain that, let's go to like a new line here. Okay, formatting is a bit messy. Let's do like this. If address contains one of these attributes, then we can say, let's also add address.notIgnored, else 0 in f, and then something like, yeah, x equals 1, y equals 2, not ignored equals 3. Yeah, so that works. And I'm just realizing that that's actually like the same as this, as address dot not ignored or 0. Yeah. I'm not sure about the precedence here, actually. Let's try to evaluate this. Maybe it'll fail. Yep, that does fail. So we need a parentheses here.
Okay.
Oh, and f is already defined. Okay, we have evaluation working again. Yeah, so that's mainly functions. Something to point out here, it's a bit of a quirk in Nix, is that function defaults work. Let's say you have well, this goes a bit too deep maybe already, but let's say you have some defaulting argument here, and then you do like at address, and then you try to check whether address contains X. Now, it's kind of an interesting question of or let's also do like, no, that's fine. So address here doesn't do anything regarding like these defaults. Address is literally just the thing you pass in. And so if you don't pass an X here, even though you can like use this X variable here, the check here will fail. It won't contain an X. Let's evaluate this. Function defaults quirk, yeah, it's false. Yeah, and so that's a bit of a catch. Yeah, then maybe we can look at some like built-in functions, built-in funds. So there is like this maybe. We have functions like so pretty much all of these are accessible under built-in stat. That's kind of the built-ins operator. So also toString is here. We have okay, let's do a list. We haven't checked out lists. I'm just realizing. But yeah, lists are just the normal thing. But something to point out is that elements are separated by spaces. So if we were to make a list of functions here, you'd have to separate them by spaces and not add any commas. So built-in sub toString, built-in sub map, built-in sub partition. There's a whole bunch of these. We can also look at these in the next REPL. Maybe that's actually a good point to mention. Let's switch to the next REPL real quick. We can also have auto-completion here, so that's nice. Built-in stat, and yeah, then we can see all of the built-ins. There's a whole bunch. There's built-ins to check the types of expressions. There's like built-ins to map attribute sets. Built-in match. Oh yeah, that's a regex matching thing. String processing. Built-in stuff false. That's interesting. To JSON, there's also from JSON to read JSON into a Nix attribute set.
Oh, cool.
Yeah. I think, did I get most of the Nix? Maybe let's like use a simple map here. Let's do like, give like numbers 1, 2, 3 in a list. And let's do like a built-in start map. And let's do like, let's give a function here. Let's say like x plus 1. Yeah, so that works, adds x to all the numbers. It's fairly self-explanatory. There's also some weird thing where you don't actually need built-in stat for some built-ins. So map is one of them. Map is valid on its own. So you'll see it sometimes just like that without any reference to where does it come from. ToString, we saw that as well. ToString doesn't need the built-in stat. But most built-ins do need the prefix.
Okay.
Yeah, then, right, maybe, what do you think of this? Are you confused about anything, or do you have a good overview?
No, it all makes a lot of sense so far.
All right, nice. Then I think let's maybe go into derivations. Now, derivations are a bit of a hard topic because, yeah, but I guess it's fine. Let's do like just a little bit about the derivation primitive or derivation built-in. So there is like this some derivation. There is the built-in derivation, and this creates a derivation. And so what is a derivation? It's a build recipe, and there's some very basic arguments you need to pass to actually make that work. Let's see, if we just do this, we should get an error. Yeah, so attribute name missing from the call. The error is, again, a bit messed up, but let's roll with it for now. So derivations need a name. Let's call this test. They also need a builder attribute. This says which binary will build the derivation. Now, this is a bit hacky here, but I'm just going to use bin shell, which is one of the only binaries available in the sandbox on, I think, all systems. Then also a system is needed. System, I'm going to use the system I'm on right now. So so Linux. And now that actually works. We can't really see the output super well here. I want to reformat this bit. Let me do like let's convert this entire attribute set into a let statement. And then add an in at the end and do a derivation built-in here. So it will declare all the things we have above, but only result in this derivation built-in thing. So yeah, we get this as an output. So what this really does underneath is that it takes all these arguments, calls some internal Nix primitive, which creates a derivation in the actual store. That's this path here. And it also tells us the output path. So this means when you build this derivation description, and we can look at this. Actually, no, we can't look at it yet because, oh god. So kind of a quirk --eval evaluates it in like a read-only mode, which doesn't write anything to the next store. We can do read-write mode to enable this, I believe. Okay, but now we should be able to look at this store path here. We can just like cat this path, and it's like a kind of simple description of how a derivation gets built. There's like output path, where should the derivation put the result when it runs? What system is it? Is it the builder and the environment variable? Actually, no, that name out. Okay, some very basic things. Now we can call next store-r. Stands for realize. We can call this to kind of manually build this derivation. You generally don't need this, but let's just go for it for now. If we try to build this, it doesn't really do anything. Next throws an error because we just call bin shell. It doesn't write the output here. That's okay. But so usually, so what we did now is this weird thing, next evaluate, strict isn't needed here, read write mode, and this, and then we copied the, actually we do need strict. Then we copied the DRV path. That's super convoluted, and then we did like the next store-realize. Under an easier way, you can just do Nixbuild. That's really just what Nixbuild does. And so if we do that, it will evaluate it and try to build it in one step. And so also I think we can just Nix instantiate to get the derivation path. Yeah. So Nix instantiate just kind of instantiates the derivation. Instantiating means to evaluate a derivation and produce it in the store so that this file actually exists. Right, and the next build is essentially just Nix instantiate plus Nix store -- realize. It first creates the derivation and then tries to realize or / build the derivation. And so let's try to fix this derivation here. There's other arguments we can pass. There's some special ones like args, where we can provide arguments to the builder. And in here, we're going to do -c and like this, maybe. So this shall take a script, execute the script, and the script writes an empty file to the out variable. Now in the builder, the out environment variable points to the output path that Nix wants you to write stuff. And so this should at least produce an empty result and build properly. Let's see, that's super slow for some reason. Okay, it worked. So we can like ls this, I guess, but it won't show anything because we didn't write anything. But now here we can of course do anything we want. We can, well, there's of course more complicated things, but for now let's do like a, can I even do anything? Can I do like, ooh, does that work? Not sure if that's valid shell. No. Next build. Nope, that doesn't work. Well, I don't know how to write to a file in the shell. Well, I guess echo might actually work. Echo foo out. Oh, right, in the ls before, but of course it's a file. But yeah, if we do a cat, yeah, we get foo now. And so when you Nix build, it puts a result symlink in your current directory pointing to the thing it just built. This way you can just do cat result as well and inspect the result this way. It's not always result, so you need to watch out a bit. Like if there's some special features that change the output link name. So this is how underneath you'd build a derivation, but you kind of never need to do this yourself because, well, for one, it's really like bin shell doesn't really work that well. you want to use more complicated things. And this build runs in a sandbox, so you can't use anything like from your home directory. So that's where Nixpkgs comes in play. Nixpkgs is the package collection of Nix, and we can use all the packages specified there already, and within them they don't use bin shell underneath, I believe, but they kind of build up this entire tree of packages from like some bootstrap binary up to kind of all the things you want to use on your PC, like Firefox, terminals, everything. And it also contains builders for derivations that make this much simpler. So let's see. Let's get a Nixpkgs in here. It's actually also good kind of lead into some other features. Right, imports. We didn't talk about imports yet. But yeah, so let's use another built-ins. That's built-ins.fetch tarball. Yes. Fetch tarball fetches tarball. Fairly self-explanatory. We can either provide the link directly. Let me do that for now. I'm going to go to Nixpkgs and like get a tarball for that, or for the latest Actually, let's just use master for now. We use this bit.com next packages archive master.tar.gz. Generally not recommended because this changes over time. Generally, you want to use pure fetches. But yeah, so next packages source, we can look at this. We can evaluate this next instantiate eval. Okay, this gives us a directory here. That was really fast, actually. Read back mode. Oh, that still worked. Interesting. Anyway, so we can, once we have a path to next packages, that actually, you can also provide a local path, actually. We didn't look at paths yet, but you can also do, if you have a local clone, you can just like source like next packages. That's where my local clone lives. Paths are also interesting. We should look at paths, but maybe not for now. So you can reference local paths with flakes, and you won't be able to anymore because this is to some degree impure because you can access anything here. But for now, it's in the Nix language. So you can also access like local paths in your project. That still works with flakes. So we could, if we had like a Nix packages clone locally, we could do that. And so once we have Nix packages, we need to import it so we can use all the packages. That's done with the import. So import takes a path to a Nix file and imports it, imports the Nix expression from that file. So we can import Nix packages like this. By default, if it's a directory, if directory uses default.nix file. So in Nix packages, in the root directory, there is a default.nix file, and that's the entry point of Nix packages. We can also manually provide this with default.nix. Like just concatenate the string to access a different file. But yeah, we don't need to do that. So if we were to just do this and evaluate this, we will get a lambda, which is another name for a function. And so the root of Nix packages is a function. And if we want to actually access the packages, we need to give an argument. And that's generally, well, that's always an attribute set. So we can use currying here. So this is just like this. But these aren't needed. So if we do that, we do get access to the set. Okay. Yes. So these are all the packages in Nix packages as a single attribute set containing all of them. All the packages and all the package builders as well. Now in this attribute set, you can provide some other options. Some common ones are overlays. With overlays, you can customize packages in Nix packages a bit. I like to personally overwrite this to an empty set because by default it reads from like config Nix packages overlays or something like that.
Yeah.
Which is kind of impure and sometimes messes with packages in weird ways. Another thing, config is by default read from some impure location. So I like to also overwrite this to the empty set. Packages config limits. And then one of the most common ones for flakes you'll see is system. That's the system type. The packages are specific to Linux or Darwin or something. And so I provide this here. You can also, this doesn't work in flakes, but in non-flake Nix, you can give built-ins.current system. That just points to your current system, another built-in. Yeah, and so in here we can, for example, say, give me the hello package, dot hello. If let's now use next build hello, it will substitute hello in 99% of, or hello, hopefully always, but some packages aren't always built by Hydra. Hydra is the CI system for Nix packages. And you have the cache installed by default, so you won't have to fetch in many cases. Right, and now we have hello here. If we build hello, we get the result symlink pointing to hello, and here we can then inspect the result. You can see that it has a hello binary, and we can execute this locally here. Result bin hello. All right. But yeah, how to actually build a derivation generally is to use the derivation builders in Nix packages. So let's say like I want to package something in some C package. It's kind of the default in Nix packages for some reason. And that's using stdn. Like standard environment contains some basic packages for building C and other related bits. And make derivation. That's the most used by far builder for packages. And so let's try just with this to see what would fail if we didn't provide any arguments. Derivation name missing. We also had that before. Name some C package. All right, and so now we get an error that we don't have a source. And so one of the main arguments here is a source. Let's, for the source, maybe pick /source. Let's actually create this directory source. Let's also do like echo foo source foo. All right, so we have at least a foo in there. So with a source, so by default, actually makefile might be good. So by default, it calls make. You have, and it's structured into phases. That's kind of the abstraction that make derivation provides. So if we just were to run it like this, we get an error, no makefile, doing nothing, no rule to make target install. So by default, for like C, you provide like makefile, then I don't have like a default which does something like echo foo or move foo to out. Oh, then it's like C makefile syntax. Then an install phase, although that's actually the install phase. I don't know. Echo bar foo. And this here. So this very basic makefile. Let's see if it works. Nix build. Okay, that works. So now we have result foo, which contains foo and bar. And so what this does underneath, it has a phases array, which gives things like unpack phase, you have patch phase, you have configure phase, you have build phase, install phase, fix up phase, and probably some more I forgot about. But these are run in order and do various things. So unpack phase takes the source here, unpacks it if necessary. So if you were to have provided a zip file or something, it would unpack that zip file into the local directory in the build. Patch phase, you can provide patches equals this. You can array of .patch files. A very easy way to apply patches to the source. Then configure phase by default calls ./configure. the default in the C world. Build phase by default calls make, then install phase, make install. And then fix up phase does like some binary fix up thing. Does some binary patching magic. Yes. And so that's really the abstraction that make derivation provides. And it's generally useful. You can customize this in some ways. So you can, all of these phases have pre and post hooks. So you can say if you want to like customize the configure phase and like run something before the /configure runs, you can say pre-configure equals and then a bash script here. So you can do like do some magic. Then you also have post-configure for after the configure. You have the same for build phase, install phase, for all the phases. Pre-build, post-build, and so on. Yeah, and so you generally use this kind of thing to build packages. Now this is the most generic builder. There's more specific ones in Nixpkgs. We're running out of time, but then there's also, for all the languages, there are separate builders. So there's packages dot Python packages dot build Python package. There's packages dot Rust platform dot or build crate or something, or build a Rust crate, I believe. Packages dot let's Haskell dot packages dot make derivation. Or call Cobbleton. There's all kinds of builders that produce derivations and take functions and have their own abstractions, things like that.
At least the naming is consistent.
Yes, let's pretend it is.
Problems in computer science, isn't there?
Yes. All right, but yeah, that's like the I think a fairly basic Nix tutorial. What do you think? Did you get most of that? Any?
I think I got a lot of it. I think I'm going to have to go back and read over the sort of the back half, the derivations up to sort of making custom derivations. I think I'll need a bit of a refresh on, but that was a really interesting introduction. Yeah, thank you so much.